All right, so we did some logarithmic equations. Now we're going to solve for some exponents. And we're going to do that using logarithms. Here we don't have anything out front. Our a and our b we're going to treat as constants. So what we need to do in order to get those x's down from the exponent is take the log or ln of both sides. I'm going to use ln. You can use log if you would like, as long as what you do to each side of the equation is the same. You can use either. That's going to let me pull down those exponents in the front. So taking the ln on both sides lets us pull those exponents down. Make sure if you're bringing down a binomial that you're bringing it down in parentheses. Okay, so the next thing we need to do is we need our x's to be together. We need to combine our x's so that we can solve for x. That's our whole goal here, was solve for x. So I'm going to leave 3x ln of a on its own for right now. Distribute in this ln of b so that I can work with that side of the equation. There's no way to get our x's together without working with that a little more. So 5x ln of b minus ln of b. Now, if I'm going to get x by itself, I need at least all my x's on the same side of the equation. So I'm going to need to bring my 5x ln of b over. Now, I'm not stacking that with a 3x ln of a because those are not like terms. Since I have ln of a in one and ln of b in the other, I can't subtract those. I'm just going to write them on the same side of the equation. And now we need to get x all by itself. So this is kind of the step where students sometimes get stuck. And what you need to think is, I have a lot of students say, well, I want to divide the x out. Well, if you're thinking divide, what you really want to do is factor. Those two terms have x in common, so we're going to factor the x out. So now that x is factored out, it's very easy to see how to get x all by itself, how to solve for x. It's tricky if you don't, that step is kind of the key here. So I'll even write that factor. So we're GCFing the x. Okay, so now we can divide both sides by 3 ln of a minus 5 ln of b. And our last step is going to be to combine. So the last thing we want is to use our logarithm rules so that our final answer looks like this. ln of a single term over ln of a single term. That's going to be fully simplified. We can't do anything to combine that division. There are no exponent rules or no logarithm rules for that. But we want to work with this a little further. So the first thing I'm going to do is power rule. So when we're condensing, we power rule first. And then we do product and quotient. Or quotient. Or what I started to write out here is it's a -1 in front of your ln of b. So power rule tells us we can take those coefficients up. I can do the same with the 3, and I can do the same with the 5. I'm going to leave that minus in between. You could make it a -5 and take that up if you want and change the sign in the middle to positive. I'm going to leave the minus in between to be the quotient rule. So here's my middle condensing step here. And then I'm going to do my I'm going to make this a little prettier. I'm going to change b to the -1 to 1 over b. That's not a 100% necessary step, but I like to use my exponent rules to keep them fresh. And then I can use quotient rule here. Minus is going to turn into a division problem. So this is going to be a cubed over b to the 5th. And that is our final answer. Now with these problems with the a and the b in them, you can get multiple answers. You may have an answer that is kind of flipped from this, like all of your a's and b's would be flipped from where these are, and that could be correct as well. So just make sure if you have something that you think like, I did all those steps, but I moved the x's to the right side of the equation. If that's the case for you, have me look at it in class, so that, because you may very well be correct, just have an equivalent solution, an equivalent correct solution. All right, that was number 7.